Alright, this last topic on integration is kind of a deep one. So you may need to watch this a couple times before you get it, take good notes. But here's the idea. I want to integrate an expression. Typically, it involves a square root, and I can't find a u prime. So if I let this be u prime be 2x. Well, I can't have a 2x over here. If I let this be u, the derivative of this would be a -1. That doesn't match here. When we wind up in this state, we have to do what's called a change of variables. And it's a multi-step process, so kind of walk here with me through it. We're going to replace every x with a u, including the dx. And so it's going to look like this. We're always going to take the part under the square root and call that u. So we're going to let u equals 1 minus x. Now, other times we would have taken the derivative of that and called u prime. It's not going to work quite the same way on this. It's called a change of variables because we're going to change every x into a u. So I'm going to solve this for x. I'll always do it this way. I'll solve this for x. So bring that over. Divide by -1. And so now I have x equals to 1 minus u. Now that I've got this, instead of finding du, I'm going to find dx. Okay, and it'll always want to work this way. We'll have dx equal to something du. In this case, it winds up being a negative du, and that's okay. I'll show you that works here in a second. But the point is, I'm going to replace the x's with what x is, which is 1 minus u. And I'm going to replace the dx with what dx is, which is negative du. So let's rewrite this problem. Replace the x with what x is. We'll go ahead and make this a negative, make this an exponent here. So this will be 1/2 pi for the square root right there. I'm going to replace 1 minus x with what 1 minus x is, which is u. Okay? So here's what's happening. I replace the x with what x is, and I replace 1 minus x with what 1 minus x equals 2. This is u right here. And the point is now I have u here and u here, and finally replace dx with du. If I do it right, I've replaced every x with a u now. And now what I've turned it into is just a distribution problem, almost going back to the very first days of integration. I can pull all this out. So 1 squared minus 2u plus u squared times u to the 1/2. Now this is a negative dx. I'll put a dx here. This negative sign is a -1 coefficient, so I'm going to move it out in front. Okay? Now, I still can't integrate this, but I can distribute it and turn it into 3 monomial terms that I can then integrate. So we have -1, the integral of 1u to the 1/2 minus 2u to the 3/2 plus u to the 5/2. All right, well, and this is all du. So this should be du right here, and this should be a du right here, and that should be a du right there. Sorry about that. So all the x's are gone, okay? All right, so now I can integrate each piece. So that's -1 times u to the 1, u to the 3/2, add 1 of that, divided by 3/2, minus 2u to the 5/2, divided by 5/2, plus u to the 7/2, divided by u to the 7, divided by 7/2, plus c, how much is c? All right, rearranging that, it's -1 times 2/3 u to the 3/2 minus 4/5 u to the 5/2 plus 2/7 u to the 7/2 plus c. Shoot the negative through. So -2/3 u to the 3/2 plus 4/5 u to the 5/2 minus 2/7 u to the 7/2. Okay? All right, at this point, I have an integrated answer. I can then replace the u with what u is. U is 1 minus x. So I'm resubstituting back in negative 2/3 1 minus x to the 3/2 plus 4/5 1 minus x to the 5/2 minus 2/7 1 minus x to the 7/2 plus, see, I screwed the signs up, so it should have been, no, signs are correct, okay? And then if I want to go one step further, I could undistribute the smallest one out, give me 1 minus x to the 3/2 times the negative 2/3, I took all that out, okay, plus 4/5 1 minus x to the 1, 5/2 minus 3/2 is 2/2, that's a 1, okay, minus 2/7 1 minus x squared, plus c. I can distribute, combine like terms, and get an answer. I'm going to stop right here for the sake of time. I can distribute, I can pull this out, distribute this, and combine all my like terms. Okay? So that's change of variables. Now that's change of variables without bounds. And with the second one, with bounds. So it's a very similar problem with bounds on it. Same process. Again, if I let this be u prime be 2, I can't do that. If I let this be u prime be 1, I can't do that. I'm going to have to do the change of variables. Always let u equal to what's under the square root sign and solve for x. So bring that over, divide by 2, and so x equals to u plus 1 over 2. All right, so that means dx equals to 1/2 du. Okay, u over 2 be 1/2 du. All right, now, so I'll replace everything with what I have. So x is u plus 1 over 2. Let's get 1/2 power here, and 2x minus 1 is u. And then replace dx again here with 1/2 du. Well, that 1/2 is going to come in front. Okay? I'm almost ready to integrate. Before I do, I also have to change my bounds, because these bounds currently are with respect to x, but all of my x's are gone now. They've all been changed to u's. So what I need to do is come over here and solve for u. It's going to look like this. The original bounds was 1 to 5. Okay, well that's x equal 1 and x equals 5. So what I want to do is go to this equation right here and solve for x. All right? So, I'm sorry, I could use either one of these actually. Probably easier to use this one. All right? So, using that one right there, I'm going to say as the integral of u equals to 2 times 5 minus 1. Replace the x with 5. And u equals to 2 times 1 minus 1. So my new bounds are going to be, that's 10 minus 1 is 9. 2 minus 1 is 1. That'll be my new bounds right there. U equals and u equals instead of x equals and x equals. So my final equation I'm about to integrate is this guy. Okay? Now everything is respect to u. Distribute this guy, we'll pull the 1/2 out of there. That 1/2 will come out to be 1/4 in front. Okay? u1 times u to 1/2 is u to 3/2. 1 times u is just u to 1/2. Integrate those, and I get 1/4 times u to the 5/2 over 5/2 plus u to the 3/2 over 3/2. All right, so that's 1/4 times 2/5 u to the 5/2 2/3 u to the 3/2. I'm going to evaluate this from 1 to 9. All right. So what I've got going on here then is, make sure we don't mess anything up. I'm going to plug in 9 and do my math, and I'm going to plug in 1 and do my math. And so I'm going to have 1/4 times 2/5 times 9 Sorry about that. Just making sure I didn't screw anything up. Okay. So 2/5 times 9 to the 5/2 plus 2/3 times 9 to the 3/2 minus 1/4 times 2/5 of 1 to the 5/2 plus 2/3 times 1 to the 3/2. All right. 2/5 of 9. Or 9 to 5/2 rather. That is going to be, without a calculator, 9 times 9 times 9 times 9 times 9. And I want to square root that, plus 2/3 of 9 times 9 times 9. I want to square root that, minus 1/4 of 2/5 plus 2/3. All right, so square root of 9 is 3, and 3, and 3, and 3, and 3. 3, 9, 81. 81 times 3 is going to be 124, 123. So that's going to be 1/4 of 2/5 times 243 plus 2/3 of 3, 3, and 3 of 27. All right, square root of 9 times square root of 9 times square root of 9. All right, minus, common denominators will be 15, so that'll be 6/15, and that will be 10/15. So that'll be 16/15 right there, times 1/4. All right, and then at this point, I think probably need to calculate for the rest of this because these are going to be big numbers. So I'll get that as 28.8 if I did it right, minus 16/60. 28.8 minus 16/60 is 28.533, or 428 over 15. If I made a math error in here, sorry about that, but the process is still the same, okay? Process is replace all the x's with u's, replace the bounds with new bounds. Good luck.